So there are lots of multiverses, actually, in physics. One of them is called the inflationary multiverse, which is we have a theory of essentially what happened before the Big Bang. Right? You have to be careful with the language. So if you define the Big Bang really carefully as the time when the universe was very hot and very dense, and as I said, you can't argue with that because we can see it, because we can look out into the sky. Our best theory of how the universe got into that state is that there was a time before that, and it's called inflation. So the idea is the universe was there, in a sense, cold and empty and expanding extremely fast. And that expansion slowed down and stopped. And the energy that was driving that expansion got dumped into space, heated it up, and made all the particles out of which we're made. And that's what we call the Big Bang. So that's textbook. It's a textbook theory called inflation. It made predictions, some of which have been tested. Some incredible predictions, actually, about the way that galaxies are distributed across the sky, because they're not just random. If you look at the galaxies, they're in sort of flows and rivers of galaxies that cross the sky in a pattern called the cosmic web. And that theory has a kind of an extension called eternal inflation, which is that the inflation essentially goes on forever, and it just stops in little patches. So you imagine the fabric of the universe, space-time, stretch, and then it slows down and stops in little patches, and each one of those patches is basically a Big Bang and a universe, of which ours is one. So you end up with this sort of picture of an infinite fractal universe of basically an infinite number of Big Bangs, and that's called the inflationary multiverse. And it answers some neat questions, because if you say, why is our universe the way that it is? Why are the laws of nature such that life can exist, for example? Well, the answer might be that all possible combinations of all the laws of nature exist in the inflationary multiverse. So then it's not surprising there are universes that permits things like us to exist, because every possible universe exists in the inflationary multiverse. And that's a well-supported theory. It's a theory, so this is not the same as saying there was a Big Bang, which we know. This is kind of, what's a theory? It's a guess, basically. But it is a theory that in its simplest form has made predictions that have subsequently been verified. So the interesting question is, what does it mean to live a finite, fragile life in an infinite, eternal universe? So that's not that funny, right? It's a good question. What does it mean to live a finite, fragile life in an infinite, eternal universe? And I think the answer is that, sort of paradoxically, whilst we are definitely physically insignificant, I've just said that the Earth is one planet around one star amongst 400 billion stars in one galaxy amongst 2 trillion galaxies in a small patch of the universe, right? So we're definitely small. You can't argue with that. We're just specks of dust. But if you think about what we are, so everybody, me and you, everybody, we're just collections of atoms, right? Some of them are as old as time, pretty much, and some of them were the other ones. Everything else, other than the hydrogen in our bodies, was made in stars, right? So we're all cooked over billions of years. And we're in this pattern that can think. So suddenly, as the great Carl Sagan said, you have a means by which the universe understands and explores itself, which is us. And that sounds unlikely when you put it like that, that you can have a few things that were cooked in the hearts of stars, you stick them together in a pattern, and suddenly it has some ideas. And so the question then becomes, well, on how many other worlds did that happen? And that's where I think the value can come in, because it's a reasonable guess that there aren't any other worlds where this happened, certainly in our galaxy. So it could be that this planet, notwithstanding its physical insignificance, is the only place where anything thinks, right, for millions of light years in every direction. And suddenly, therefore, you end up considering this planet as being the most valuable place in the local universe, notwithstanding the fact that it's small. And that idea, it's not just a complete random guess, by the way. We've had a bit of a look. Astronomers have pointed radio telescopes up at the stars for a while, 50 years or more now, and heard nothing. We've seen no evidence of any civilizations out there beyond Earth, and that's a surprise. There's a reasonably plausible explanation for that, which is biology, which is that if you look at the history of life on Earth, then you see that life began pretty much as soon as it could here on Earth. We have evidence there was life 3.8 billion years ago, something like that. And the Earth's 4.5 billion years old, so pretty quick in geological time you get life. But then if you talk about advanced life, complex life, multicellular life, then there's no evidence at all. You look at the Milky Way and you look at that arc of stars across the sky, 400 billion suns. All there will be up there at best is slime. It's just slime. I mean, I wouldn't be surprised if that's wrong. Then you go, okay, good, well, fine. But at the moment, it looks like there isn't anything else other than slime. We haven't even discovered slime, by the way, yet. We're still in the position where we've not seen anything, not even a single cell on Mars or the moons of Jupiter or somewhere like that. So at the moment, we are alone, as far as we can tell.